Hi. There was a comment asking for MIDI support and providing several protocols and standards to look into. So Untoward asked, is there any way to use a MIDI sequencer via wifi-midi, like if the DS hosted a web page that could be used to connect the app to a software or hardware MIDI? He suggested to support RTP-MIDI aka Apple MIDI or Web-MIDI by having Noise Commander host a web interface. I tried a few things and we got Wi-Fi-MIDI in Noise Commander, either via DSMI or a VST3 plugin made in Juice. The big caveat though is that Noise Commander has a fixed latency of 43 milliseconds. The latency might be quite a downer and essentially means that running Noise Commander as a MIDI receiving instrument is not a real option at this point. As a sender, Noise Commander sends the MIDI events with a 43 milliseconds delay to match with the audio, and this works quite well as far as I can tell. And using MIDI keyboards or drum pads just for input works pretty well too. So here's the story. I tried to get DSMI running with Nitro Tracker on the 3DS, but it just crashed. After seeking around on Discord, somebody mentioned that I need to configure the Wi-Fi and the DS, and I learned that only certain games such as Mario Kart provide the option to configure Wi-Fi in the first place. And then it just worked out flawlessly. I was very happy. Just kidding. I couldn't connect because instead of WPA3, it needs a WEP passphrase, which my Wi-Fi router does not support. I gave up at this point. The last code update of DSMI on GitHub was 13 years ago and it uses Qt4. After tweaking the project file a little, I was able to compile it in Linux. There was also support for iPhone, but people on Discord said it would be probably a pain in the ass to get it to compile nowadays. So DSMI has a very simple approach. It creates a virtual MIDI port in the operating system and then sends or receives raw MIDI messages via the UDP protocol. The UDP protocol is connectionless, which means that the sender does not care or check what happens to the data once it was sent. Packets may be lost or received in an unexpected order, but it has less overhead compared to TCP as it skips any bookkeeping or error correction, which helps with latency. So I got this working fairly quickly, but running DSMI with ALSA in Linux isn't exactly fun or user-friendly. Without running Jack and the A2J MIDI bridge, the virtual MIDI device is not listed in some DAWs, so it's a hit and miss. Renoise seemed to be the most forgiving here, Reaper less so. So I had the idea to make a VST3 plugin with Juice. It's an instrument which consumes and produces MIDI. Unlike DSMI, this does not create a MIDI port in the operating system, so you need to connect it to other instruments inside the DAW or VST host if it supports it. I'm happy to report that I am able to route the Noise Commander VST MIDI to other instruments in Reaper, Renoise and Bitwig Studio. However, initially I was observing a drift in the timing of sent out MIDI signals. It seemed that Wi-Fi jitter was just unsuitable for MIDI. The way I tested this was to play a sample and a MIDI note at every beat. I observed that the shift would reset itself every 30 seconds or so, like a saw wave. After modifying a bunch of things in my code to understand the root of the problem, I concluded that this feature was dead and useless. All the effort wasted, MIDI would never be a thing for Noise Commander. I then moved on to implement a metronome feature. I did a similar test with playing a sample every beat and listening to the metronome. It had the same 30-second saw wave drift. I should mention that the code was playing the metronome separate from the main audio engine. The latter is being streamed in chunks to the first of the 24 channels on the T-Crud chip. What this told me is that something in my code was causing the drift. The Wi-Fi wasn't to blame. When I laid out the problem to my wife later during our evening walk, I realized what was happening. Similar to screens and games, the audio is being double buffered. The new audio buffer is being computed while the previous buffer plays. The sequencer clock is embedded in the audio code and uses the current audio frame position for precise timing. However, the buffer is computed not in real time but faster than that. If this wasn't the case, then audio dropouts would occur. I tried a fix right in the next morning and it proved to be correct. The fix was to count only the audio frames passing in the first buffer as it actually plays at the correct speed. To cut the story short here, my next hurdle is to compile the Juice VST plugin for Android. At the moment I only see a white screen, something is wrong. But I rage quit and decided to stop here to finally make this video. I won't be able to make an official release during the next few days, as I have to take care of some normie life things. If you are a paying Patreon, however, you can install the current temp build via the dedicated updater app. When clicking on Collections, Paid Member Only Downloads, Optional Updater / Installer app, you will find further instructions on the Patreon site. However, you also need to compile the Juice VST plugin for your operating system, as a binary is only released for Linux. See the GitHub link in the description of this video. So this is using the lossy UDP protocol, but ultimately you'd want support for Ableton Link and or Apple MIDI aka RTP MIDI for a painless mobile setup with iPads and such. These are much more complex and would take more effort to implement, so I cannot make any promises, but it may be a thing in the future. Another train of thought was this scenario where you'd want to use Noise Commander for MIDI only, without its audio features, and thus without latency. Please let me know whether this would be important to you. I initially thought this would be easily achievable in the code, but alas I realized that it's a bit more involved than I would like it to be. If you are following along and want to try connecting Noise Commander to the VST app, here is how. First install Noise Commander 0.1.0 temp via the Updater app. Open the plugin in your DAW or run the standalone app from the zip file. Click on Discover 3ds in the plugin. In Noise Commander, press D-pad down twice to see the MIDI settings. Tap on Discover VST3 server and wait a couple of seconds. If it succeeds, then it will enter and display the found IP address, else it may show 0000. Now you should see the MIDI messages appear in the plugin's log when pressing pads in Noise Commander. Currently only MIDI notes are handled. You can change the current instrument's volume with CC20, but not much else. Configuring and managing MIDI channels and control messages will be implemented in the future.